When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
Halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Hello dear students, how are you all? So all of you are preparing the exams for the boards. Next our aim to crack the board with utmost percentage, 99.9% equal to 100% we have to score it. So we brilliant team is with you to help you in every aspect of the exam. So board exams, you know, most crucial area, 16 questions of MCQs are there, plus 2 case study based questions are there. So total 24 marks are there for 1 mark each. Out of 16, which all MCQ type questions you can expect from each chapter or unit wise that we are cracking for the many last few days. Now few more sessions are for you. Today I am with you for 2 chapters to solve. Electromagnetic waves and semiconductor devices. 2 easiest chapter of the syllabus we can say. So hope all of you are ready for that. Electromagnetic waves, if you go through 3 marks question you can expect in the board examination. And semiconductor devices, 7 marks you have to expect in the board exams. So out of the 3 marks from EM wave, definitely 1 question will be MCQ. And in semiconductors, sometimes you used to go 2 MCQ questions. One may be assertional reason or both may be objective type questions. So let's see for the past few years which all questions came from these 2 chapters as multiple choice questions. Hope you are ready. So let's start. Yeah, many are there online. Yeah, please share the link with your friends also. Let's do this 1 hour. Let's make these 2 chapters perfect in the case of MCQs. So with questions we'll be explaining the theory also. Okay, stay tuned. We'll start with the first question. Yeah, here's the first question. In the process of charging of a capacitor, the current produced between the plates of the capacitor is. So it's a EM wave question, electromagnetic waves. The beginning case, what is the origin of electromagnetic wave? If you think about it, you might remember Maxwell's and Ampere's theory. So Ampere's circuitous law, Maxwell has modified by introducing a concept called displacement current. Is it? So that idea actually you have to use it. Displacement current. The current in between the plates of a capacitor, parallel plate capacitor, due to variation of electric flux. That's called displacement current. Its equation is given by I is equal to epsilon 0 d phi e by dt. A 2 mark question also you can expect regarding this. Derive the expression for displacement current. So here direct answer for epsilon 0 d phi e by dt is the displacement current. C is the correct answer. Is it? Yeah, you got the answer. I hope you are doing it. So here epsilon 0 d phi e by dt is the answer for this. Yeah, many are correct for this. Let's go for the next question. When an intrinsic semiconductor is doped with a small amount of trivalent impurity, then what will happen? So this question is from semiconductors. You know, semiconductors, conductors and insulators, if you compare, Semiconductors, basically they are insulated, but as the temperature increases, they become more conducting. And in order to increase the conductivity, we can add the impurity atoms, like from 13th group or 14th group we can add. So that two more types of semiconductors will get P-type and N-type semiconductors. So 14th group elements, silicon or germanium, are the most common semiconductors. If you add or dope a 13th group or trivalent impurity with the silicon or germanium, then we will get P-type semiconductor. You remember it? Then if you dope the 15th group like antimony, bismuth, phosphorus and all with the silicon or germanium, you will get an N-type semiconductor. See the question. When an intrinsic semiconductor means the pure form of semiconductors. There is no impurity, just equal number of holes and electrons. Electron hole pair are equal, and that's done because of thermal vibrations. Then if it is doped with a small amount of trivalent impurity, so trivalent you are adding, so 13th group, see options, there will be more free electrons than holes in the semiconductor. No, trivalent have one deficiency of electron, so we will be getting holes. Its resistance increases. Resistance actually we cannot say, because as based on temperature we have to include, or number of terms, I mean the number of charges per unit volume also we have to check about it. It becomes a P-type semiconductor. Yeah, that's more accurate, I hope. Dopant atoms become donor atoms. No. So here donor is actually done by 15th pentavalent group only. So here it becomes a P-type semiconductor. P-type, that P stands for two cases, you can say either previous group, so you are getting P-type, or positive type. Positive means more number of holes are created, so answer is C. P-type semiconductor. Answer is C here. Hope you are getting it. Okay, yes. Next question we can do. So okay, you type your answers in the chat box. Okay, chat box, many are there here. Let's see. Yeah, great. Let's go through it. So we can see the concept here. Let's see. See the becomes a P-type semiconductor is the correct answer. Next question we can do. In the energy band diagram of N-type silicon, very important, N-type silicon, the gap between the bottom of the conduction band EC and the donor energy level ED is of the order of. Okay, so in what order will be this? So when you draw a energy band diagram, we have two bands, conduction band and valence band. Is it? So in that one, for this N-type semiconductor, we are doping silicon with the pentavalent. So more number of electrons are there on conduction band because of the doping itself. So if you draw the band diagram, we have valence band here and we have conduction band with a small separation, CB. In CB, we have more number of electrons here in compared to valence band. So valence band we have holes also, remaining electrons we have more number. There a donor energy level is there just below conduction band. Between them, what is the difference of energy? You know, it is almost equal to 0.01 electron volt. So electrons from valence band can jump to this donor energy level, from there easily they can come to conduction band. So conductivity increases. So here option is between this EC and the donor energy level. This is the donor energy level. This is EC, the conduction band. The level difference will be 0.01 electron volt. D is the correct answer. Yeah, perfect answers are there. Yeah, Sanjay is there. Hisham is there. Great. Option D is the correct answer. 0.01 electron volt. Very good. Let's go for the next question. Again from semiconductors. An AC source of voltage is connected. So AC source is connected in series with a PN junction diode and a load resistor. The correct option for output voltage across load resistance is, so output what will be? You know, a diode, our PN junction diode have a great application in our daily life as a rectifier, remember. A rectifier is a device which converts AC to DC. AC will be converted to DC. Alternating current is converted to direct current. What we use in all the battery devices like mobile phone, laptop, anything to charge, we plug in. So from plug we have AC, we converted by the charger or the adapter to DC, and the battery stores the current in the form of DC. Is it? A single diode will act as half wave rectifier. 2 diodes will act as full wave rectifier. So 2 types of diodes we have, rectifiers we have. So with a PN junction diode, a single PN junction diode will act as half wave rectifier. So you might remember, if an AC of the waveform like this way is passed through this single PN junction diode, then the output will be only 1/2 will reach there. Why? When the diode is forward bias, only it will conduct the current. The theory you might be knowing. So full wave rectifier, a sure 3-mark question from the chapter. Based on that, a 1 mark is came here. So a full wave AC is given, then output will be of course only half of the AC cycle will be there. So here the option, yeah, Isham is given. Very good, very good. Sanjay is there. Yeah, Krishna is there. Yes, fine. Answer is C is the correct answer. Only single halves will be there. Only positive halves. Great. So full wave rectifier, a sure question for the 3-mark area. You do it. Based on that 1 mark MCQ also came. Just waveform, input and output waveform, AC is applied. If it was 2 diodes, 2 PN junction diodes, if you pass through, then your answer might be this one, full wave rectifier. Both halves has positive wicket. Got it? And if you connect a filter circuit at the output, then nearly equal straight line current will get it. The ripples will be removed. Is it fine? Okay, let's go for the next question. It's again from electromagnetic wave. Okay, yeah, Isham is there. Krishna is there. Sanjay, yeah, come on. See, vector E, electric field, and vector B, the magnetic field of an electromagnetic wave respectively. Then the direction of propagation of the wave is along. So direction of propagation of electromagnetic wave, if you see, we might have studied in the theory part. Electromagnetic waves are transverse wave. The direction of propagation is perpendicular to both the components of the wave, that is electric and field, magnetic field. So E and B are there, then to both it will be perpendicular. So perpendicular direction, you know, we get X. Yeah, A cross B will be the concept. So cross product, check it. So E cross B will be the answer for here. Option C is the correct answer. Yeah, great. Many got the answer. Very good. Sanjay is there. Yeah. Pinky is there. Yeah, great. So Isham, it's clear. See, now one more option is there, B cross C. It won't be B cross C because no, B cross C also a perpendicular, but in the opposite direction it will be. So electric field and magnetic field are there, then E cross B will be the perpendicular to both. Is it? So cross product depending on the direction. A cross B is not equal to B cross A, so answer is E cross B here. Is that fine? Okay, so electromagnetic wave is a transverse wave. Based on that, this question came. Okay, this all questions today what I am going to discuss is from the previous year past paper questions only. So get the idea. Frequently these concepts are repeated. Okay, let's go for the next question. Again from semiconductor chapter. Okay, in an extrinsic semiconductor, the number density of holes is 4 into 10 raised to 20 per meter cube. Number density means number of charge carriers per unit volume. If the number density of intrinsic carriers is 1.2 into 10 raised to 15 per meter cube, then number density of electrons is how much? A small numerical. In semiconductor now, this year only one equation you have to go through, which is separated from current electricity. Resistance you can find normal current electricity formula. Other than number density, one equation is there. Just keep in mind the number density of electrons into number density of holes, Ne into NH, will be equal to number density of intrinsic charges to the square time. Is the relation. Ne into NH is equal to Ni square. Is the exact equation. Number density relations. Number density of charge carriers, holes and electrons, if you multiply, will be equal to number density of intrinsic charge carriers square. See, in the figure is given. In the question, number density of holes is given NH 4 into 10 raised to 20. Then number density of intrinsic carriers, that is Ni, is also given. You have to find number density of electron. Direct one. Is it? Yeah. Okay. So check number density of electrons, you have to get it. So Ne is equal to, it will be Ni square by NH. Direct question. Hope you get the answer. Okay, quick. Please try all of you. Yes, it will be equal to Ni is given 1.2 into 10 to the power of 15. That's you have to square it. So 1 more time. Into 10 raised to 15. Divided by NH is given 4 into 10 raised to 20. 4 into 10 raised to 20. Simple calculation. So make it 14. It is 12. 12 by 4 is 3. Make it 12 is 14. So 14 plus 14, 28 is there. By 20 is there. So plus 8. 3 into 12 is 36. So 36 into 10 raised to 8 is answer. It will be 36 into 10 raised to 8 per meter cube. Check the answer. Yeah, here option is 3.6 into 10 raised to 9. So correct answer is C. If you just one more decimal, you get 3.6. Yeah, Sanjay got the answer. Pinky, great, great. Okay, Sham is there. Yeah, great, great. Yeah, Venkat is there. C, got the answer. Clear, clear. Okay, let's go to the next one. So semiconductors and EM waves, alternate questions are coming. So from each question paper I selected this one. Please do it or perform it well for this MCQs. Okay, hope you will. Let's do the next one. Pieces of copper and of silicon are initially at room temperature. Both are heated to temperature T. The conductivity of. So regarding conductivity is the question. One piece is of copper and one is of silicon. Copper and silicon, you are very familiar. Copper is the most common conductor what we use in daily life, and silicon is most common semiconductors what we use in daily life. So both two pieces are there. Their conductivity regarding, when temperature increases, for conductors the resistance or resistivity increases. Hence the conductivity will decrease. For conductors it become more resistant if temperature increases. But the best application of semiconductor is this much only. If temperature increase, then semiconductor become best conductors. So their conductivity increases. So option is here. Therefore the conductivity of both increases? No. Both decreases? No. Copper increases and silicon decreases? No. Just reverse. Copper decreases and silicon increases. So conductivity of copper will decrease because its resistivity increases. Silicon will increase. So this is a concept for that's D. The same question you can expect from current electricity chapter also. The one equation you might study it, rho, the resistivity of the conductor in terms of relaxation time. I hope you might remember, students. Is it rho is equal to m by n e square into tau. One equation is there from chapter current electricity actually. There n is the number density, tau is the relaxation time. If temperature increases, the relaxation time will decrease for the conductors, hence rho will increase. So it will be up for conductors. And for semiconductors what happens? This n will decrease. So number of charge carriers will increase to the multiple time if temperature increases. As n increases, this is become up, that rho will decrease for semiconductors. So this is for conductors, this is for silicon. So resistivity decreases, the conductivity increases. This is the theory behind it. Hope you got it. So semiconductors, this concept is linked with the current electricity chapter also. Copper is a conductor, silicon is a semiconductor. Let's go for the next question. Okay, great. The formation of depletion region in a PN diode is due to. So PN junction diode, a P-type semiconductor and N-type semiconductor, if you club together, it form a PN junction diode we call it as. So P-type and N-type semiconductors you mix together. In that formation, the depletion region is formed because of what? So along the junction, a region will be formed because of diffusion of charges. From P region, the holes will diffuse into N region, and from N region, the electrons will diffuse to P region. Because of diffusion, there will be depletion region. So movement of dopant atoms, diffusion of both electrons and holes, drift of electrons only, drift of holes only. Simple, the diffusion of both electrons and holes. Yeah, how many of you got the correct answer? Yeah, great, great. Nima is there, G is there, Sanjay is there, Venkat is there. Yeah, good, great. So B is the correct answer there. Diffusion of both electrons and holes is happening. Great. Okay. Yeah, Mr. Dikya, Sanjay is there. Yeah, great, 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 great. Next one. The ratio of the magnitudes of the electric field and magnetic field of a plane electromagnetic wave is. So from EM waves it is. Again, the ratio of magnitude of electric field and magnetic field. Ratio will be what? That means electric field magnitude E by B. The amplitude, if you got it, E0 by B0 maximum value you can put, or simply E by B will be equal to what? There's a relation with the speed of electromagnetic wave. That is nothing but the C will be there. the speed of electromagnetic wave. How much it is? 3 into 10 raised to 8 meter per second. This is the value of C. For electromagnetic, all the electromagnetic waves move the same speed, you know. E0 by B0 will be C. So here, option is C is the correct answer. Yeah, option C, answer is C. So 3 into 10 raised to 8 is there. Including our visible light, all the EM waves moves with the same speed. Got it? So E by B. The same terms you might be gone through in moving charges and magnetism also. But that topic is deleted now. Velocity selector one concept was there. Then also E by B will be equal to the speed V will be there. From that idea, this also here. E by B is equal to C. Okay? Yeah, great. Many got that? Yeah. Moses is there? Yes. Venkata is there? Yeah, Sanjay. Okay. Keep active. We'll do the next question. Again from EM waves, the chapter. See, EM waves I told you out of these 3 mark, surely one will be objective. Sometimes maybe 2 also can come like that. Okay, so either assertion reason or MCQ based questions will be there sure. An electromagnetic wave is produced by a charge. See how easiest the question it is. The production of EM waves, electromagnetic waves, the origin by Heinrich Hertz, the scientist actually practically successful it was to demonstrate the production of EM waves. When a charge moves, we produce current across that, around that we have magnetic field. And if charge is accelerated, variation of magnetic field takes place. It in reverse it produces electricity. So variation of electric and magnetic fields produces the EM waves. So an accelerated charge can produce EM waves. That's the basic idea of the production of EM wave, isn't it? Yeah, many got the idea. Good. So a charge moving with a constant velocity? No. Constant velocity, what happens? Uniform motion is there, no variation, fluctuation in magnetic field. Moving with a constant speed parallel to magnetic field, no chance. Constant speed, no chance. Moving with an acceleration, yeah, great. So option C is the correct answer here. Moving with an acceleration. So a charge moving with an acceleration produces EM wave. That's a basic way of producing an electromagnetic wave. So combinedly varying electric and magnetic field produce the EM waves, and it transfer energy from one position to another position. That is the electromagnetic wave. Okay, great. So options, yeah, almost all of you got the correct answer. Great. So keep putting your support. Yeah, great. We'll go to next. A semiconductor device is connected in series with a battery, an ammeter and a resistor. So some devices are made up of semiconductors. A current flows in the circuit. So when they connected with the battery, ammeter and resistor, a current flows through it. If the polarity of the battery is reversed, the current in the circuit almost becomes zero. The device is a or an. What is the device name? So actually the application of the diode is asking to reverse the question. That's all. That's it. See, normally a conducting wire, a copper wire, you connect across a circuit. You can send the current from left to right also, right to left also. That's a conducting wire. But the most important application of diode, a PN junction diode, is it allows the conductivity or current in one direction. It is a unidirectional device, a PN junction diode. Actually, question is that meaning. Is it? First is connected, current passed. When you change the polarity of battery, no current passes. So 2 words you might remember there regarding that: forward bias and reverse bias. Forward and reverse biases. In forward bias, current passes through. Reverse bias, no current passes through across the diode. So only diode is used as a rectifier. Here answer is PN junction diode. No doubt at all. D is the correct answer. Yeah, very good. Sanjay, Isham, yeah, everyone got correct answer. These are Moses there, Venkata is there. Yeah, thank you all for support. So please keep watching, give your support. Next question, let's see. Yeah, again from EM waves. The electromagnetic radiation used to kill germs in water purifiers. Yeah, direct application type question. See, whenever we discuss the theory of this chapter, I told you from this chapter, sure question regarding the applications. We have 7 waves, all the 7, at least 2 to 3 applications that you should go through it. Out of this one, a normal student also can give it, not to study physics at all, because it will be written, all the water bottles, mineral water bottle will be written, what treated? To kill germs? Yeah, great. Yeah, option D is the correct answer. Ultraviolet, UV treated water, you know. UV ultraviolet is an electromagnetic wave. It is used to kill the germs inside the drinking water. So, great, ultraviolet radiations. UV rays are used. Okay, good. Yeah, there is the correct answer. Isham. Nima, good, good. Everyone got correct answer. EM waves, another application level question. Next, we can do. Yeah, again from semiconductors, another chapter. I mean, another question, set of question paper. So it look like similar. Can all we solve it? Quick. At a certain temperature in an intrinsic semiconductor, the electrons and holes concentration is 1.5 into 10 raised to 16. So that is the number density of intrinsic charge carriers. So Ni is equal to 1.5 into 10 raised to 16 per meter cube. When it is doped with a trivalent dopant, means extrinsic it became, hole concentration increases to 4.5 into 10 raised to 22. So here NH is given how much? 4.5 into 10 raised to 22 per meter cube. In the doped semiconductor, the concentration of electrons Ne you have to find out. See dears, just before I got the similar equation in another question. So here concept a little bit changed, that's all. Same equation you have to use it. What is? You have to find Ne. What is the equation? Yeah. Venkat got answer. Great. So here Ne is equal to Ni square by Nh. Just before we got Ne into Nh is equal to Ni square. Just square it and divide. So answer, it become 1.5 into 10 raised to 16. The whole square divided by Nh is there 4.5 into 10 raised to 22. So it is, yeah, 15 by 14, 1 by 3 is coming. So 15 by 3, 5 will be there. 5 into 10 raised to, so 0.5, is it? Yeah, 0.5 into 10 raised to, it is 32 by 22, 20. Yeah, 5 into 10 raised to 9 will be the correct answer. C is the correct answer. Is it? So, okay, Venkat, please check the answer. Yeah, Rudya is there. Muhammad Isham is there. Just like check it. So 15. So it will be 15 into 15 by 45 is coming. Yes. Make it up. 3 is there. So 5. Is it? Yeah, correct. Joss is there. Yeah. Rudya. So it will be C is the correct answer. 5 into 10 to 9 per meter cube. Okay, so it's again a question from that semiconductors. The beginning equation is there in the which relate number density of holes and electrons with the intrinsic number carriers. Okay, fine. Next question, let's see. If a PN junction diode is reverse biased, a direct question. PN junction is reverse biased. What is the meaning of reverse biased? A junction diode will represent like this way. If you connect the P, this is the P region and this is the N region of the diode. If you connect with a different opposing polarity of the battery, this P type comes to negative and N type goes to positive. A simple connection. A simple circuit diagram I'm doing. So you might be studied reverse bias characteristics and the forward bias characteristics using ammeter and voltmeter connection and everything. So here negative 2. In that what happens? The potential barrier is lowered. The potential barrier remains unaffected. The potential barrier is raised. The current is mainly due to majority carriers. So reverse bias means, you know, the majority charge carriers move away from the depletion region or the junction. They move away. So the depletion region width increases. So as the depletion region width increases, the potential barrier height also increases, so that no majority charge carriers will cross. So check which is correct answer. Yeah, come on. Yeah, very good, very good. Nima's got answer, G got, okay. Sanjay is there, Joss, okay. See, the correct answer will come as C. The potential barrier is raised. If it is reverse biased. And if it is forward biased, what happens? The majority charge carriers, that is, holes from P side and electrons from N side, they move towards the junction. As they move towards the junction, the depletion region thickness or width will decrease and the potential barrier will decrease. It will be lowered in forward bias. So just opposite be the answer. Got it? So please keep in mind that idea. Forward bias and reverse bias. Okay, let's go for the next question. At 0 Kelvin, the resistivity of an intrinsic semiconductor is. So intrinsic semiconductor means a pure semiconductor. For a pure semiconductor, what will be at 0 Kelvin? Just before I told you, 0 Kelvin, the semiconductor will be a purely insulator. When temperature increases, it becomes more conducting. Because of thermal vibration, the bonds will be broken. So electrons, free electrons are created. Free holes are created. So they'll continue to move, hence the conductivity starts. So at 0 Kelvin, it will be an insulator. So come on, option. Yeah, great, Sanjay. Venkat, you got it. Very good. Nima got. So answer is what? Infinite. D is the correct answer. Keep in mind, not at 0 degrees Celsius. It is at 0 Kelvin. From 0 Kelvin, as temperature increases. For conductors, the resistance increases. And for semiconductors, the resistance or resistivity decreases from 0 Kelvin. Okay, that's the idea. Just opposite. So only semiconductors we are using most of the electronic devices. It become hot, its conductivity become increases. It become better conductors as the temperature increases. Okay, let's go for the next question. EM wave, again the next question. Electromagnetic waves of wavelength of the order of few meters were first produced and detected in the laboratory by, yes, just before we mentioned about it. First experimental successful was with Heinrich Hertz. So option C is the correct answer. Maxwell put forward the theoretical support. You might remember that one. The 4 equations Maxwell grouped together. There in ambient circuit he found some little bit deficiency. He cleared it. Then he forward variation of electric flux can produce a current. So it can produce a magnetic field cases. So that way electric and magnetic field changes will produce electromagnetic waves. From there Hertz produced it. Got it? Great. A capacitor is charged by a battery between the plates during process of charging. So capacitor concept in the first question we explained already. If you while charging the capacitor, only displacement current exists, only conduction current exists, both displacement current and conduction current exists, no current exists. So between the plates of a capacitor, normally it is free space, air is there. Air is an insulator of current, so no current passes. But capacitor is connected with the conducting wires. Through the wires, conduction current is there, and in between the plates, what happens? That was a question with Maxwell. He put forward the idea there is a displacement current happens. Hence the circuit completes. So that displacement current is because of electric flux change, variation in electric flux. Hence the answer is what? Yeah, great. Nima got it. G is got, Venkata got, Sanjay, great. Can I know what is this? G, A and all? Great. Your full name please. Yeah, Venkata, exactly, correct. So only displacement can exit there, A is there. Okay, dear students, hope you are following it clearly, is it? Enjoying it. So EM waves and semiconductors we are doing, changing. Okay, let's go for the next question. For the forward biasing of a PN junction diode, which of the following statement is not correct? For the forward biasing of a PN junction diode. Forward bias. Forward bias means what? If a junction diode is this is the diode, here is the P region, here is the N region, and forward bias means we connect positive of the battery with P region and negative of the battery with N region. So we'll get this way. It's a simple connection of the forward bias. In forward bias only the diode will conduct electricity. We got it? And reverse bias it do not, almost equal to 0. Both have application. Forward bias it conducts, so we use in rectifier. Reverse bias it do not conduct. So there is a special diode called a Zener diode. We use in voltage regulator, that one. Okay, this year's syllabus is not mentioned. Previous syllabus already was there. So here regarding forward bias is a question. So forward bias, which of the following statement is not correct? Very important, which is not correct is the question. Okay, yeah, answers came. Great. Let's see. The potential barrier decreases, minority. So forward bias, I told you the potential barrier will decrease as a correct answer. But here it is not correct, you kid. Minority carrier injection occurs, width of the depletion layer increases is given. No. Width of the depletion what happens? Decreases, because majority charge carriers will move towards the junction. So width will actually decrease, but here is given increases. Forward current is due to diffusion of both holes and electrons. That's also correct only. So not correct is the answer question. So option C is the correct answer. Okay, actually the width of the depletion will decrease, but it increases given, not correct is answer. Negative is question. Okay, yeah, KD, great. Krishna is there, Venkata is there, Nima, okay, great. C is the correct answer. Direct question. See how easy the questions it is. So in semiconductors, only just one equation you have to keep in mind. That is it. Ne into NH is equal to Ni square. Only numerical part there. Remaining all are practical oriented questions are we are expecting. Okay, let's go for the next question. Yes, Aditya came. Great Aditya. So next question is, the electromagnetic waves used in radar systems is, radar you know, all of you know what is radar. Radar is actually radio detection and ranging. Radar we use, in many cases we use it directly, the flights and all. Aircrafts we use it, speed interceptors in the roads and all, you know, radar cameras are there to detect the speed of a vehicle and all. What it's used by? Infrared waves, ultraviolet, microwave, X-rays. Yeah, correct answers. Yeah, great. Direct options. Practical oriented question it is. Microwaves are used. Radar. So may I ask one more idea? Infrared waves. Where we use infrared waves? Can you answer? Yeah, NDS Sahil is there. Great, Sahil. Keep firing. Great. Sri is there. See, infrared we can use for many purpose. One direct purpose there. You know barbecue cooking? In barbecues, all the hot bodies gives the infrared waves actually. Barbecue we never use flame, is it? Okay, so that will give the infrared rays we cook it. Infrared we use in the remote controls of AC, TV and everything. Remote controls make use of infrared. Then night vision camera, photography, the CCTV cameras are there. Night vision they use infrared rays. Even you know the James Webb telescope, it uses infrared rays. Lot of applications are there for infrared. Actually for all the EM waves, 2 waves are used for cooking. Can you say which all are? Microwaves and infrared is there. Okay, Nima great. Vengat. Yeah, pain therapy of course, that also is there. Physical therapy will call us. Then ultraviolet, UV already we just mentioned about it. UV lamps are there. Then UV rays we can use for the killing the germs in the drinking water, mineral water to purify the water. UV rays we call it. Then for skin treatment also, for few cases UV can be used. Even it helps the plant growth. Sometime once a question came like that. Which EM wave support the growth of the plant in earth? Ultraviolet only. Microwaves we got it. Microwave ovens we use microwave for cooking purpose. Then in radar system also microwave we can use it. Then X-rays of course the most we used to say the word. We used to take X-ray. Actually say medical scanning diagnosis purpose we can use X-rays. Many goes in baggage radar and the airports, the baggage screening they use X-rays are there. Okay, scanning purpose we use X-rays. Great. This all uses you should keep in mind because be helpful for this EM electromagnetic spectrum. The order you keep in mind. Then at least 2 each uses of each waves you do. 1 mark definitely can score it in this MCQ. Surely 1 question will be there regarding that. Okay, let's see the next question. The threshold voltage for a PN junction diode used in the circuit is 0.7 volt. So threshold voltage is 0.7 volt. The type of biasing and current in the circuit are. So threshold voltage is nothing but the potential barrier. The minimum voltage required to a diode to conduct current. That's called the threshold, the potential barrier or threshold voltage we call other name. Okay, that's given 0.7 volt. Then in the circuit, which biasing is there and what is the current is going. So biasing, yes we got. We have 2 biasing, forward bias and reverse bias. See, this is the positive of the battery. So we connect that with the, this is the positive. So it is connected to the P region. This is the negative of the battery is connected to N region. So positive of polarity to P region, negative to N region. Which bias? Yeah, forward bias is there. So option would be either forward biasing, forward biasing. It cannot be, it cannot be. So biasing is forward bias. Now what is the current you have to check? See, the barrier potential is 0.7 volt. Now when the external potential what you give is greater than 0.7, then only there will be a current in the circuit. That's the logic here. See the external potential how much? It is just 0.5. It is not sufficient to make the majority charge carriers to jump across the potential barrier. Because potential barrier how much? Barrier potential or threshold voltage is 0.7 volt. It is just 0.5. So no current passes through the circuit. 0 ampere is the current. Yeah, option is A is the correct answer. Great, Sanjay got, Venkata, great. I got it, Chris. Yeah, Chris, you're back. Sanjay is there. Yeah, great. Correct answer is 0 ampere. Forward biasing and 0 ampere. Great. So forward bias, the minimum voltage, the barrier potential or threshold voltage should be overcome by the external potential. Then only current will be there. Till that 0 current is there. You might be done a practical PN junction in forward bias. So during for small voltages, there will be no jumping of current. So 0.7 ampere is there for this germanium and 1.1 volt is there for this silicon. So till 0.7 volt external, no current. After 7, a sudden increase is there. Is it? Most of the majority charge carriers will cross the barrier. Theory. Okay, let's go for the next question. Yeah, it's an assertion reason type. Okay, let's see. Great, Chris. Okay. Yeah, assertion. In N-type semiconductor, the number density of electrons is greater than the number density of holes, of course. But the crystal maintains an overall charge neutrality. See, remember, we discussed that question. Suppose this pen is made up of N-type semiconductor. What is the charge of the pen? Never go for negative. Charge of pen will be neutral, 0. So, it's correct. Assertion is correct. Though neutral charges, I mean this N-type semiconductor, N is for negative, so negative charge carriers are greater than that of holes, still it will be neutrality, correct only. No reason. The charge of electrons donated by donor atoms, the pentavalent atoms, is just equal and opposite to that of the ionized donor. Same, is it? So the number is more, but total as a whole, an electron is negatively, 0 charge, neutral will be, because equal number of that ionization will also happening there. So number there. Exactly. So both assertion and reason are true. Then in this assertion reason type questions, we have 4 options. Both are true and reason is correct explanation of A. Then second, both are true but reason is not the correct explanation. Then one is true, another is false, or both are false. So the option here A will be both are correct and correct explanation is there. Okay, very good. Hope you got it. Chris, you have to check it please. Okay, great. That's all. Yeah, Navina is there. Got it? Great. Thank you, Navina, for support. Yeah, Venkata. Good. Great. Sanjay. Let's go to the next question. Again from electromagnetic waves. Okay, it's a challenge for you. Give me the answer for this. Name the electromagnetic wave also known as heat waves, which is called heat waves. Just before I explain about it. Come on, give me an answer for that. Yeah, great. Yes, Sanjay, yeah, all of you, very good. Everyone gave the correct answer. Good. So, heat waves are nothing but the infrared wave. Just before I told you, for cooking purpose, we can use 2 EM waves. One is infrared and is microwave. The heat waves are called infrared waves. Clear? Great. So, all the hot objects emit infrared. Great. So, let's go for the next question then. Which one of the following electromagnetic radiation has the least wavelength? Least wavelength which have out of the given, which is the least is asking. Okay, see, when we discussed about the theory case, the electromagnetic spectrum, a small code you can use it. The spectrum order. Any order you can keep it. One order which I can suggest to you. G, X, U, V, I, M, R. Yes, it's nothing but not a code at all. The first letters of each waves. G for gamma rays, X for X-rays, U ultraviolet, V visible light, I infrared, M microwave, R radio wave. This is the order of increasing wavelength lambda. Increasing wavelength, ascending order of wavelength. This code, if you study now, 1 mark you can secure it. Either they will ask to arrange in ascending order or descending order, or they will ask which has the highest or lowest wavelength or frequency. If it is ascending order of wavelength, then this is descending order of frequency. So frequency just changes opposite. Nu will be opposite. So gamma waves have the highest frequency and lowest wavelength. Highest wavelength for radio waves, least frequency for nu. If nu is given, lambda you can find out, and if lambda given, nu you can find out, because the speed c is equal to nu into lambda. Frequency to wavelength is there. So these all items you can club here. So come on, out of the given, which is the least wavelength is asking. Gamma, visible, microwave, X-rays are there. So least wavelength they are asking. So answer is what? Gamma rays. Is it kind? Yeah, great. All of you gave the answer. Great. So A is answer. Yes, Venkata. Exactly. Correct. Then suppose the question is which of the following has highest frequency? Your answer will be Again the same, is it? Gamma rays. Highest frequency and least wavelength will be throughout the spectrum, it will be gamma. Okay, then if the gamma is there, you can answer for that. Okay, then out of the given, which have the longest wavelength? It is, will be microwave, the longest one, because it's near to radio waves. Okay, microwaves you can use for communication purpose also. Okay, fine. Let's go for the next then. Yeah, again a question from the semiconductor devices. During the formation of a PN junction, just but all ideas are there. Diffusion current keeps increasing, drift current remains constant. Both the diffusion current and drift current remain constant. Diffusion current remains almost constant, means minute variable will be the variation will be there, but drift current increases till both current become equal. See, there are two types of current, diffusion and drifting. First, diffusion will be there, soon after keeping the p type and n type together, diffusion of holes takes place. Because of that attraction, electrons will be drifted. So diffusion and drifting both are there, is it? And it will follow till both become equal. Then the junction is formed. Depletion region will be there and a barrier potential will be there. Is there a formation? That is a PN junction formation. Clearly you might be studied there. So regarding that is a question. Yeah, answer is there. Yeah, Venkata, Sanjay. Yeah, everyone gave the correct answer. Good. So it is D. The diffusion current remains almost constant. So you might study diffusion current a little bit increase. Then after that drift also increases. Both will become equal after that. Okay, they're only almost constant they mentioned. Clear, all of you? Yeah, good. Nima, you got the answer now. Great. Okay, let's go to the next question. Hisham, are you there? Next one, assertion and reason again. Assertion. The resistance of an intrinsic semiconductor decreases with increase in its temperature. Resistance of an intrinsic means a pure semiconductor, decreases with increase in temperature. Yeah, that's correct. That's only the application of semiconductors. When it is heated, temperature increases, its resistance decreases or resistivity decreases. So assertion is true. Reason: the number of conduction electrons as well as hole increases in an intrinsic semiconductor with rise in temperature. Yeah, surely solid is increasing, number of charge carriers increases, because when temperature increases, because of thermal vibration, the covalent bond breaks, so electron get freed and holes are created. The vacant place is called hole, positive charge. Because of the movement of electron, the carriers move and we get current. Both are correct and answer is A. Is it? Assertion, reason, both are correct, and reason is correct explanation of assertion. Is it? Yeah, great. Sanjay, yeah, all of you got the correct answer. Great. Next question, let's see. Choose the correct option related to wavelength of different parts of electromagnetic spectrum. Yes, just before I told you, one question may be arrangement of these wavelengths. So, tell me, what's the code? GXUVIMR. 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 5 times you keep it in mind. GXUVIMR is the code. Is the increasing order of wavelengths. Come on, what is your answer? Check. So wavelength of gamma side is least and radio wave side is greatest. First option check. X-rays lesser than microwave, of course. Microwave lesser than radio waves, okay, but no, visible is less than radio wave and microwave, so it's wrong. A is wrong. Second, visible is greater than X-rays, of course. X-ray is greater than radio waves. No, never. Lambda of radio is the greatest one after the given. Radio wave greater than microwave, greater than visible, greater than X-rays can be. Is it? Yeah. C is the correct answer. Great. C. D. Visible less than microwave, less than radio wave, X. So never can be. So C is the correct answer. Radio wave, microwave, and all. Great. So that's correct answer. Yeah. Sanjay, Hisham, everything. Great. Sanjay, Menon. Great. Next, let's see. Assertion. Again, assertion reason type. In insulators, the forbidden gap is very large. You know the forbidden gap or energy gap between two bands, valence band and conduction band, is very large for insulators. So only never an electron, valence electron can come to conduction case in insulators. So only they are insulators always. Conductors, there is no energy gap, they are overlapped. So most of the electrons in valence band are conductions. And semiconductors, small gap is there. When it is heated, they can come to, or they get energy, they can come to the conduction band. That's the logic what we have. So assertion is correct. Reason, the valence electrons in an atom of an insulator are very tightly bound to the nucleus. Yeah, of course, they are strong bounded. So they cannot be free. There is no free electrons in insulators. So both are correct. Assertion and reason is correct. Reason is a correct explanation of assertion. So option A again here is the correct answer. Is that clear? Yeah, great. Brendan is there, Isham? Okay, great. Okay, fine. Next. Yeah, silicon, just before we discussed about. The energy required by an electron to jump the forbidden band in silicon at room temperature is about. So, the energy required for, what is the value of energy gap? That's a question actually. So, to jump an electron from valence band to conduction band in a pure silicon, how much it will be? I told you for silicon it is 1.1 electron volt and germanium it is 0.7 electron volt. So answer is 1.1 electron volt. Direct theory questions. D is the correct answer. Yeah, great. Nima, Hisham, Sanjay got everyone. Good. 1.1 electron volt is answer. Okay, dears, these are the questions what today we discussed. Almost EM waves and semiconductors. Few last previous year questions. All we gone through it. So I hope you keep in mind. Once more, electromagnetic waves, minimum 3 mark question you can expect. Out of this, one surely it will be MCQ type. Semiconductor chapter, 7 mark question you can expect. Out of this, 2 MCQs you can expect. Minimum like that. So please be thorough on the topic. See, almost all the questions are direct practical oriented questions. Only one numerically expected from semiconductors regarding the number density, N E into NH is equal to Ni square. Remaining all are practical type questions. Okay, so yeah, all are there. Thank you for support. Yes, Isham, thank you. Brendan, Isham, yeah, great. Adul is there, great. Nima is there, Sanjay, everyone, great. So please stay tuned for the next sessions are there. Upcoming days also you will get the sessions. All the chapters we are discussing here in these live sessions. So please watch the previous videos also when you prepare. Within half an hour, 1 hour, you can secure your marks in MCQs. It's a inherent part in the exam paper, 16 direct one MCQs are there, 1 mark questions. Then 2 case-based study questions are there. So there are also 8 marks you are getting. So thank you for watching and support. We'll see you in the next session. Thank you all. See you all. Great.